Let's go by another way. We can also solve simultaneous equation, the graphical method. So it depends on the equation that you are dealing with, okay? Either the equation is linear or the equation is quadratic. It can also be cubic. So we know that if it's a linear equation, then we are going to get a straight line. If it's a quadratic equation, we'll get a curve. If it is also cubic, we can also get a curve. All right. So here we will treat the quadratic equation, quadratic function, that is getting the curve. We'll do that one specially. So let's look at when we have a linear equation, as we have solved question on the elimination and the substitution. So that the questions we have solved so far is on linear. So let's also look at the another linear equation, whereby you can also use the graph. You draw your straight line and the point of intersection where they will intersect. Okay, that will be the value of x and then the value of the y. All right. So it is a linear equation, and when you draw your graph, let's say you have your two straight line. Let's say this is whatever 3y plus 5, just an example, and this is, let's say 6x minus 7y equal to -3. So when you are solving, if these are our straight line, assuming where they will meet their point of intersection, you trace down to this is our x axis, this is our y axis, and then let's say the value of x here is a, the value of y here is b. So where they will meet or where they will intersect, you trace to the x axis, trace to the y axis, and the two values you get are the two values that will satisfy the two linear equations at the same time. So that is what we are going to do. Okay, so let's look at this question. SSC November 2005, question 7a. It was question where you draw your straight lines, or you are given two linear equations, and then you are asked to find the value of s and y. So you are using the graph, that is your two straight lines, to find the value of the s and y. And I have told you that, or we know that when you have linear equation, what you get is a straight line. If it is quadratic, it will be a curve, and so on. So using a scale of 2 cm to 1 unit on the x axis and 2 cm to 2 units on the y axis, draw the graph for the straight lines y plus 2 is equal to 1 and y minus 3 is equal to 11. So these two can be solved simultaneously by drawing the graph and the point of intersection, okay, where the two lines meet. You trace the x and the y axis to get your two values for x and for y. All right. But before we can draw our graph, okay, on the Cartesian plane, that's the y and the x axis, we need the coordinate or the points. Okay, so we are giving y plus 2x to be equal to 1. Okay, so we need and when you want to draw a line, at least you need 2 points, at least 2. One will not be enough because you may not know where the other point will pass. But when you get at least 2, then that is enough, 2 or more. So you pick a convenient value, okay, for the x, and then you substitute to get y, and vice versa. Or you pick a convenient value for y, you substitute and get what? Your x, and you get your point. You do that. Okay, so we can even also go by the y or the s intercepts. Or you say when s is 0, y is 0, and then and so on. So you are going to determine the points you are going to, but make sure to pick a convenient point so that you can get your value. Okay. So here we can say when x is 0. Okay, so that we can get our corresponding y value. So when x is equal to 0, then what to do? I do substitution. So y plus 2 times 0 is equal to 1. We substitute x into where? Into the equation. Okay, so what do we have? So y plus 2 times 0 is 0. Y plus 0 is equal to 1. So our y is what? Our y is 1. Here will be 0. Okay, so y is 1. So what will be our point here? S is 0, y is 1. So we have gotten our point, okay? One of the points as s is 0 and y is what? Y is 1. But we need another point too, so that we can get our straight line. At least we need 2 points. Okay. So what can we also say again so that we can get another point? All right. So we can also choose another value for. We can say that when x is equal to, or when y is equal to -3, so that when the negative 3 can become positive 3 and we get 4, so they can get a value for the x. So let's say when y is equal, let me pick for y is equal to negative 3. All right, so looking at picking a point depends on you. Okay, pick a good point, a convenient point that you can get on the graph, and then you plot. Sometimes you may pick a particular value for either s or y, and you may get decimals, which will be difficult to locate on the graph. That is why you have to look at the equation you are given, pick a very convenient value, and then you can easily locate on the graph so that you can get your value. So when y is negative 3, so in the equation I have negative 3 plus 2x is equal to 1, and then 2x will be equal to 1 plus 3. All right, and my 2x will be equal to what? What is 1 plus? That will give me 4. 4 over 2 will give me 2. So what is my point? X 2 and then y negative 3. Okay, so for the straight line, let me write it here. Y plus 2x equal to 1. We have the points on this straight line. Okay, we have the points as what? 0 1, you can get 0 1, and then we also have another point as what? 2 negative 3. Okay, so these 2 points are enough to draw your straight line. We have 0 1 here, s is 0, y is 1, and then here s is 2, y is negative 3. Okay, so let's look at the other equation as well. The other linear equation is y minus 3x equal to what? 11. Y minus 3s to be equal to 11. All right, so here we can say when s is 0, so that we can get the value of the y easily. Okay, when x is equal to 0, then y minus 3 times 0 will be equal to 11. And then y will be equal to 11, because this will be 0. So what will be our point? 0, positive 11. Okay, so with this particular curve here, okay, so we have our points as what? One of the points is 0, negative 0, 11. Okay, let's follow. Then what do we also do again? We have gotten one of the, we left another point. So let me pick a negative value for the x. All right, so that when I pick the negative value for the x, this will be positive, and it will go here to be negative and reduce the value for the y so that we can get it on the graph. So simple. So I'll say that when s is equal to let's say negative 2. Okay, when s is negative 2, then my y minus 3 times negative 2 will be equal to 11. Okay, so I'll substitute negative 3 here. So negative 3 times 2 will give me positive 6 equal to 11, and y will be equal to 11 minus 6, and that will give me 5. So what will be my point? Negative 2 and then 5. All right, so I have my point as negative 2, positive 5 for this particular equation here, negative 2, positive 5. So we have been able to work our points out. So what now is left is to draw our graph. What is left now is to draw our graph. All right. Okay, so let's get our scale using a scale of 2 cm to 1 unit on the x-axis and 2 to 2. So let's look at our points here. We are drawing 0 1, 2 negative 3, and then 0 11 and 2 negative 1. Okay, so we are using what? 2 cm to 1 unit on the x-axis. Okay, and then on the y-axis we are using 2 cm to 2 units. All right, so you have to draw it in such a way that you get your values. So on the x-axis, this is my x-axis, 2 cm to 1 unit. Okay, so 2 cm to 1, so 1 2 3 and say 4, negative 1, negative 2, negative 3. Okay, that's okay. On the y-axis too, so the highest, look at the x values, 2 negative, so I have 2 here, I have -2, I have 0, 0, so I'll get all of them there. On the y-axis 2 is going to 2 units, so let me have my 2, 4, 6, 8, 10, 12, that's okay. So when I look on the y-axis 2, I have 11, 5, -3, and then 1, so let me get my -2 here, -4, -6, that's okay. Alright, so now we can draw our straight lines. The equation y plus 2 equal to 11 is 0, 1. So s is 0, y is what? Y is 1. That can be here. Between 0 and 2. And then 2, -3. S is 2, y is -3. So -2 between -2 and -4. So that one can also be here. Alright. So what we'll do is to draw a straight line, okay, to pass through. Okay, so the straight lines will pass through. So you can extend this small. Okay, so that we have our 0, 1, which is here, and then 2 and -3, which is also here. Okay. Now let's come to the second one. We have 0, 11. So 11 is here. And then we have -2, 5. S is -2. Y is what? Y is +5. +5 is between 4 and 6. So here. And then here. Okay. So we can also get it to pass through here and here. So our line will pass through these 2 points. Okay, so this is also a straight line. This is what? Y minus 3 is equal to 11. And this straight line is what? Y plus 2x equal to 1. So these are 2 straight lines. So what we now have to do is to look at their point of what? Intersection. Okay, and then so that we can find the values of s and y. They intersect here. So I'll trace this to the s-axis, y-axis, and trace it down to the s-axis. So the point of intersection here is what? -2 and +5. -2, +4. The values of s and y. The values of s and y are -5 and 5 respectively. So s is -2, y is what? Y is 5. -2 and 5. So this is what you are going to get if you use let's say elimination or substitution method to solve this to what? Equation. The value -2 and 5 will satisfy this equation. Alright, so this is how the graphical method can also be used to find the values of s and y from 2 linear simultaneous equation. I believe this is understood. Okay, we'll also get and look at quadratic, how sometimes you even use the graph to solve for quadratic and linear equation at the same time, and so on. Alright, I will see you once again as we solve more questions on simultaneous equation. Bye bye.